In Lesson 8 from digits, we're going to compare two linear functions. So if you take a look at the graph there, it describes a blue robot's yards per second and red robot's yards per second in a contest. So it says that we are supposed to find, or how did the scientist rig the race because he knew that his blue robot was too slow to beat the red one. So how did he rig it? So if you take a look at where they started, he started his blue robot 50 yards ahead of the red robot. And our y-intercepts tell us that information. The next question is how much faster than the blue robot does the red robot run? So we're going to take a look at the rates. The speed is the rate. So if we take a look at the rates here, the blue robot goes up 10 yards every 2 seconds. So the blue is 10 yards every 2 seconds. So he travels 5 yards per second. If you take a look at the red one, it goes up 10 over 1. So the red robot is 10 yards every 1 second. So that's 10 yards per second. So the question was how much faster? So red is 2 times faster than the blue. Again, red is 2 times faster than blue. Alright, let's take a look at the temperature problems down below here. We have 3 different cities, Eastbury, Hilltown, and Topperville. And for each city, there's a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 o'clock. Which function has the greatest rate of change, and what does that mean in the situation? So, rate of change would be the unit rate. So if you look at Eastbury, we can see that the temperature increased 3 degrees per hour. So the rate of change is 3 degrees per hour. If we look at Topperville, here we have an equation, and the rate of change is the slope, and I can identify the slope as being in front of the h. So this tells me that Topperville increases 2 degrees per hour. And then in Hilltown, we can see that the rate of change is the change in y's over the change in x's. So this is consistent throughout. It goes up 2 degrees here every hour here. So that's consistent. So the rate of change is 2 degrees per hour for Hilltown. So to answer the question, the function that has the greatest rate of change is Eastbury. And the rate of change is how much the temperature increases per hour. So this means that Eastbury's temperature increased 3 degrees per hour. Alright, so now let's take a look at comparing the initial values of the temperatures. So we're talking about this problem over here. Compare the initial values of the temperatures for the 3 cities, and what do the initial values mean in this situation. So if we take a look at Eastbury, it says the temperature was 62 degrees Fahrenheit. That is the initial temperature. If we take a look at Topperville, the initial temperature is the initial value, the b value in the function, so that's 54. And Hilltown has initial temperature of 58 degrees at 6 o'clock. So let's put that in some writing there. So what I wrote is that Eastbury's initial temperature was 62 degrees, Taperville's is 54 degrees, and both of those were at 8 a.m. Hilltown's was 58 degrees, but that was at 6 o'clock a.m., so we should not compare that to the other cities since it was at a different time. Alright, now let's go to this case here. If you graph the three functions on the same set of axes, what will be true? Okay, so we're graphing on the same set of axes. What will be true about the lines that represent Eastbury and Hilltown? So if you take a look at Eastbury and Hilltown, Eastbury's temperature is increasing at 3 degrees per hour. Hilltown's is increasing at 2 degrees per hour. And they start at 8 o'clock. Eastbury starts at 8 o'clock at 62. If you look at Hilltown at 8 o'clock, it also starts at 62. So at 8 o'clock they're starting at the same point, but Eastbury is increasing faster. Then when you compare Hilltown and Topperville, both of those increase at 2 degrees per hour. Hilltop starts at 54 degrees at 8 o'clock, and at 8 o'clock Hilltown is 62 degrees. So that means that the lines will be parallel since they don't start at the same temperature, but they increase at the same rate. So you may need to pause your video to copy that down. Again, Hilltop and Topperville will be parallel since they increase at the same rate, but are not the same temperature at 8 o'clock. Alright, moving on to the next page. The functions below describe temperatures in degrees Fahrenheit on the same day in two different locations. Which function has a greater rate of change, and what does that mean in the situation? So if you take a look at the wording here, it says it decreased 2 degrees per hour. So the rate of change is negative 2 degrees per hour for Funtown. In Schuster, we look at the rate of change, which is the slope, and that's the number with the variable. So here, we're looking there. The number in front of the variable is called the coefficient. That is negative 2. So Schuster is also going down 2 degrees per hour. So which one has the greater rate of change? They are the same. And this means that both towns' temperatures are going down at the same rate. So make sure that you get that copied, pause if you need to, and let's go down to the next problem. We are comparing the initial values of the function, and what can you conclude in the situation? So the initial value for Funtown is 70 degrees at 4 o'clock, and at Schuster, same time, 4 o'clock, the initial value is 72. So what can we conclude about the situation? So since both towns' temperatures are going down at the same rate, and Schuster starts 2 degrees warmer than Funtown, we can conclude that Schuster's temperature will always be 2 degrees warmer than Funtown's. Alright, now we are ready for our Google to make sure that you understand what you have learned here today. So go to the questions here, and I will ask you to put your answers into Google form. So for number 1, you are going to write the letters of the two linear functions of the lines that do not intersect. So you're going to write A and B, B and C, C and D, A and D, etc. So you're going to write 2 letters of functions that don't intersect. Then, for number 2, you're going to look at the graph here, and you're going to tell me which 2 lines have the same rate of change. So you would put, for example, 1 and 2, or 2 and 3, or 1 and 3, etc. So for number 2, you're giving 2 lines that have the same rate. And for number 3, 2 lines that have the same initial value. So your answers should be numbers 1 and 2, 2 and 3, or 1 and 3. For number 4, when 2 linear functions have the same rate of change and the same initial value, what do you know about the graph of the 2 lines? So you're going to tell me what you know there. Alright, you will not have to do number 5 here, so I'm going to cross that off. And the bit.ly is bit.ly/adesso8-4.